All right, so in this section, we learned that completing this course is one way to become a PCQI. We know that this particular regulation built on old regulations that are still in use today and can be used in conjunction with other regulations. Maybe you're following juice HACCP. Maybe you're following acidified food regulations. Maybe you have other programs in place like halal or kosher or an organic program. So there could be all kinds of systems that you have that you're working with for this. Another system would be something like Safe Quality Foods. That's that third-party certificate that's recognized globally that would give you access to larger companies like, say, Walmart. So essentially it proves that you are maintaining food safety and quality and improving on those things. The whole idea behind this is to reduce the risk for the public as well as for your business. And of course, make sure that you complete the exercises. Participation is really important in this class. That is the expectation for passing. There are no quizzes, there are no tests. So it's really about making sure you put your all into those exercises. All right. So in this specific section, we get to review what goes into your food safety plan. Now remember, your food safety plan has to be specific to each facility. So say within your company, you have 2 separate facilities, 3 different distribution centers. Each of these requires a different food safety plan because they are, of course, not all the same. Different equipment, different people, different processes. So it's going to be different considerations, maybe even different products. That's a pretty normal setup. Now, when you do your hazard analysis and you identify a hazard that is significant, right, meaning it's pretty likely to occur, it's going to cause severe illness and injury, and you decide it definitely could be a problem, we want to prevent that from being in our food to protect our customer, we have to put a preventive control in place. That is required. It is also required to have a recall plan at that point. Then you also have to have implementation procedures around each preventive control. So that's monitoring that preventive control, saying if you potentially have an issue occur and you might have unsafe food, that you're aware, and then you do your corrective action, otherwise proving that you are actually, in fact, maintaining control. So you have records around all of that, and verification around each preventive control, and validation specifically of those process controls. So say I need to prove that my cook step works, I would do a study where I would go through my cooking procedure for, say, an oven and make sure that if it's running at this speed, at this temperature, for this amount of time, with this airflow, that I am, in fact, killing that pathogen. When it comes to building your food safety plan, writing all of these things, writing your standard operating procedures, your format's flexible. You can absolutely do it however you like. There are templates available to you in the course materials. A lot of people use that, but not everyone does. Sometimes you already have great formatting within your company system. You want it to all match and be the same. The most important thing is that when somebody comes into your facility and they're doing an audit, whether it's a regulator or a third-party auditor or a second-party audit from a customer, you want to make sure that they understand what's in that plan. So it needs to be clear, it needs to be accurate, it needs to be written in a way that you know that anyone who has access to it can use it and understand it. Good manufacturing practices and prerequisite programs cover so much, from making sure that you don't have mice running around rampant in your facility and having a pest control program like those traps that you use to catch them that you can monitor. Don't use poison. If you use poison, the mouse can die anywhere. It's not good. From that to having screens, to making sure that your facility in general is maintained clean, to controls around allergens that are just our good manufacturing practices like gowning, using color-coded instruments, right? having filters in your airways. Right? Those can all be considered good manufacturing practices, as well as equipment maintenance and making sure your employees are trained. So it's people, processes, product, plant, and procedures. Those are our GMP Ps. So at the end of the day, you have a safe product. So say I'm making something like chips, right? And I have a process where I fry those chips. Well, if I'm making those chips I could be making them out of anything, right? I could be making them out of potatoes or kale or tempeh. Any of those things I just mentioned could potentially be contaminated by some kind of pathogenic bacteria, right? They all come from plant material. Plants grow in the ground. We use manure to fertilize things. That manure wasn't processed properly, potential contamination. We use water to water our plants, right? That water comes from streams. Generally speaking, wherever we are growing things like leafy greens or plants, there's usually other farms around them too. And I'm talking like animals, right? Like cattle, pork, chickens, that kind of stuff. Those animals poop. When it rains, that collects and goes into the water system. And because of the way we handle our animals in America, they tend to be like densely packed. So if one of them gets sick, they're all likely to get sick. So you see a higher rate of contamination of microbes in that situation. So that's getting run off into the water, those pathogenic microbes. Then you're also risking the potential of, say, a fly landing on a cow plop, and then that flying over to your happy soybean that you're going to use in your tempeh and contaminating it there, or into your green for your kale, right? Can also travel over on wind, right? A microbe can definitely fit on the foot of a dust mite too. So there are lots of different ways for potential contamination, and within your system, say you're deep frying to kill off those microbes, right? Maybe you did a clean and a wash to start with, and you have different processing methods like the ferment to help manage those. And you also have your deep frying kill step. Great. What happens if I have a ton of oil splatter everywhere, and now I've got oil buildup in specific areas, and then I'm not cleaning well enough, so I grow a biofilm. And now that biofilm is a source of contamination. And say I go to squeegee the floor where that buildup is, and now I'm just spreading those microbes everywhere I squeegee. I mean, I did everything I could to try to implement my controls, and then I failed at my cleaning GMP, and now I'm spreading around pathogens. So things to think about. We got to train our people effectively to make sure that we are following those basic programs to ensure safety. Our biological hazards can include a variety of different types of microbes. So we have pathogenic bacteria, which we've already spoken of a whole bunch. We also have mold. So mold can create mycotoxins. Not all mold. So some mold is used in food production. It's healthy. It breaks down the food for you. It's really great to use. So we use koju when we make sake or when we make miso. We use mold when we make tempeh. In those particular two examples, say I have an accidental contamination of a similar mold, but not the same kind of mold, there is potential for these different kinds of molds to develop toxins within those fermented products. And those toxins can be really harmful. They can cause things like mycotoxins can eat away at the lining of your digestive tract. Some of them can even make ulcers on your eyeballs. Most of them will make you vomit, right? So when you drink your sake, you might be vomiting for some reason other than the alcohol. And some, if you get a high enough dose, can even cause death. So those are things to think about when you think about mold. And those toxins aren't necessarily destroyed by fermentation processes or by cooking. They're still going to be there if that mold produces it in the food. Things to think about. The next one I want to talk about is viruses. So viruses act differently than our mold and our bacteria. They actually need a host to reproduce. And so basically what happens is a virus infects a cell. It could be a plant cell, an animal cell, a bacterial cell, even another virus. They use the inner workings of that cell to replicate themselves because they can't do it alone, right? They just don't have the machinery. So they infect the cell. They use the inner workings of that cell to reproduce themselves. When they've produced enough, that cell splits open, it's called lysing, and the virus spreads. Viruses can survive freezing temperatures. They can survive on surfaces for very long periods of time. They are very hardy, and they are harder to identify because, one, they're very small, smaller than our microbes. And two, if they're just sitting on the surface of our food, they're not reproducing. They're not going to reproduce until they enter our system because they have to infect a living host. So things like norovirus, which we call the stomach flu, it's an example of a virus for you. And then parasites. So parasites come in a couple varieties. Yay, fun. So we have parasites that are unicellular. Things like Giardia, right? You hear when you go hiking in the woods, make sure you filter or boil your water because you don't want to end up with Giardia. It's bad news. Yeah. There's another one that is interesting. I like to talk about this one because of the way it works. So it's living in the ground, right? And it gets into a mouse. This particular parasite can actually change the brain chemistry of the mouse. So it makes the mouse less scared of things, and it makes it attracted to cat urine. So now this parasite has convinced the mouse to run to the cat. Cat eats the mouse. That parasite wanted to be in the cat, super happy on the cat. So now you have somebody who owns a cat and they're scooping out litter every day. Cat has the parasite. Maybe the cat goes to use litter box, scratch, scratch, scratch in the litter box, and then goes to see its owner and boom, scratches their owner, potentially infecting them with Toxoplasma gondii. That one has actually been linked to mental illness, can cause issue with your eyes and your sight. That is one of the colloquial reasons we call it crazy cat lady syndrome. Yeah. Now, worms, on the other hand, I'm sure you've heard of tapeworms. Pinworms are the most common worm in the United States. And I know some of you probably saw those videos a while back where they would pour soda on a piece of pork and see the worms crawl out. Pork does tend to get infected by worms. They even form little white sacs called cysts that are cut out of your food before you get it. It's one of the reasons that we cook our pork so thoroughly. And worms, they transmit pretty easily from one person to another. So be careful because say you're handling some meat and it's pork, and some of the blood gets on your skin. Those eggs can actually get to you transdermally. Or if you don't wash your hands well enough, you touch your mouth, and you've just infected yourself with worms. Now those worms, they can reproduce sexually inside of your system. And when the female goes to lay her eggs, she will exit the butt at night, lay her eggs. Apparently it's quite explosive and it makes it itchy. And so the person goes to scratch themselves Then they accidentally touch their mouths and reinfect themselves. I heard a crazy story about somebody who got infected from worms from an illegal food truck where he got pork tacos. So he gets these pork tacos, he's got bad cramps, he's not feeling well. It takes a long time for him to feel better. He never quite 100% recovers. He doesn't realize it's the taco truck, and he goes back again a month later. Gets the pork tacos again. But this time, he's having some neurological issues like brain fog and headaches, and he doesn't know what's going on. So he goes to the doctor, and they find out he has 2 types of worms, both from the pork. So that pork was infected with worms. It wasn't cooked well enough, so he got the first kind of worm that infects your stomach, your GI tract. The second time he came back, he got infected from a human that was infected with worms. In other words, the guy cooking the food had worms and then didn't clean his hands well enough after using the bathroom, handled his pork tacos, and transferred some worm eggs into his food, and from that, he got a brain worm. Welcome to Biological Hazards. Definition of a hazard: any biological, chemical, or physical agent that has the potential to cause illness or injury. Now, I want you to notice that they included radiological under chemical hazards. That is new. The reason they decided to include that is because we've seen an increasing number of accidents around nuclear power plants. So you may be familiar with Chernobyl or Fukushima. When you have an accident of that size, it is going to affect the air, the water, the ground, everything growing in the area, and all of the living things within that area. And that radiation, it lasts for a really long time. And so there have been some people who have been continuing to grow things in this site. There was a company that decided to harvest trees from Chernobyl to make into paper boxes to put food in that were still emitting radiation. Mm-hmm. There's a company that makes liquor that decided to do it as a shtick, where they harvested some potatoes from the area, making irradiated vodka. Not sure whether or not that one's safe. My personal opinion says no. I would want to see some scientific studies about that before I drink that. The important thing about your biological hazards is to identify for your specific food product what likely biological hazards you might see. So for example, if I'm looking at those pre-made salads or vegetable trays, I might look at recent outbreaks, and I would see that Cyclospora has been a particular problem, as a parasite, in those products. And so I'd be like, okay, that's something to look out for, right? So you just look at guidance from regulators or studies or information from the group that basically the association for whatever product you're making. They've already gone through this process and they know what's likely to potentially affect your product. So it's just important to do the research to see, all right, what seems like it could be an issue that's likely to be an issue that I need to make sure that I put a control in place. And there are lots of different ways that we control biological hazards, which we are about to look at. Ideally, we'd like to prevent contamination. So that's doing things like good agricultural practices where we make sure that, people who are harvesting are washing their hands. It's pretty challenging when you think about it. Making sure that produce isn't harvested from the ground, because if it's touched the ground, then it's likely to be bruised or damaged, or something may have gotten on it. And then paying attention to other practices along the way, like how do things get stored, right? Lots of different ways that contamination might happen that we can prevent up front. And so when we're looking at preventing contamination, it's going to be a lot of things like, what can our suppliers do for us? What can we do along the way in our processes, in our own environment to prevent contamination, right? So that's what a cleaning is about in large part. Storing things in dry places, paying attention to the temperature at which we're storing things, all of those go hand in hand with preventing contamination. Killing them. This is the one we're most accustomed to in our daily life, right? So we cook things to kill microbes. Now, there are different methods for killing things like radiation, using chemicals. We do use chemicals a lot, like when we process meats, you dip it in a chemical bath, a little bleach, kill off those happy microbes. Some of these microbes are harder to kill than others. So, for example, spore formers. So we have our regular bacteria, right? But some of them have this spore inside of them. And say you're canning a product. So when you're canning it, you are pressurizing it, you're heating it up, and you're causing a vacuum, right? So if I have vegetables from my garden, I put them in a mason jar. I put some water and some salt in there. I put it in my pressure cooker. That pressure cooker heats it up. All the air gets pushed out of that jar. When it cools down, then that jar is technically vacuum sealed. There is a microorganism called Clostridium botulinum, or CBOT for short, that tends to be, in the ground. And if, say, your beans that you canned were contaminated with it and you weren't able to wash it off during your processing, if it were in that jar, the outside of it would deteriorate, but that spore would survive. CBOT's a spore former. Once it got back to room temperature, now it's in an environment where it's happy, because CBOT likes to grow without oxygen. So some microbes like oxygen, some microbes do not. So CBOT, super happy. There's no air in there. And it starts growing because it's got food. It's so happy. It's good to go. It's at the right temperature. That spore goes back into a vegetative cell. Those vegetative cells split, form more cells exponentially. And CBOT makes a toxin that, if you consume it, will paralyze your diaphragm and kill you. That toxin is pretty useful when it's not in our food. We actually use it for things like TMJ, for headaches. We also inject it into our face when we don't want our wrinkles to stand out because we don't want to look old anymore. So Botox. Thank you, spore former. Yeah, CBOT's definitely one to look out for. The other way that we manage bacteria is we control their growth. So oftentimes we do that through limiting their access to water. So maybe we dry out our food products, or we add things like salt or sugar to preserve them. We also can use microbes. So we promote the growth of healthy microbes to outcompete the pathogenic microbes. We do things like manage pH. So if my pH is below 4.6, I'm not growing CBOT. I'm good to go. Temperature is one we're used to. We pop things in the fridge, right? So that we're not growing too many microbes, so that we can keep our food for longer and eat it longer safely. There's a big difference between how long your potato salad lasts in the sunshine at the picnic on a 90-degree day versus in your refrigerator at a happy 40 degrees Fahrenheit. So I mentioned some of these methods for killing microbes earlier. Heat, you can use acid to completely kill them. You think about something like lemon juice. If you let your lemon juice sit out on the counter, nothing's really going to grow in it. Same for your hot sauce, right? Chemicals, radiation, ultrasound, pulse light, high pressure, all of these get used in different processes. You think about pasteurization, high pressure, high heat. Then how long we apply these things, what temperature we get to, what the food is, how the composition of the food, so like how thick it is or how dense it is. So think about the difference between cooking a chicken nugget and cooking a turkey. Massive difference there. Cooking a turkey that doesn't have stuffing versus a turkey that does have stuffing. Again, differences in how long you have to cook it in order to make it safe. Well, thankfully, we've had lots of scientists do studies where they look at how long these things need to be applied in order to kill off these microbes. And we also have Appendix 4 in our materials where we can look at ways to inactivate Listeria monocytogenes, which, interesting fact, I make a fermented drink called Ch2 from the rinds of pineapples. And the microbes that grow in Ch2 are actually great at fighting Listeria. It's pretty cool. We have an acronym that helps us remember what cause bacteria to grow. So things that influence their growth, it's called fat TOMs. So food, acidity, time, temperature, oxygen, and moisture. And so it's important to pay attention to those things because that's what we're going to control to limit growth or to kill microbes, or if we're doing a ferment, promoting the growth of those probiotics to fight those bad microbes for us. Also listed here is preservatives. So we use lots of different nitrates, sulfates, ascorbic acid. We have lots of different methods for inhibiting the growth of microbes through one way or another. One thing to consider when you're writing up your controls and building your food safety plan, reducing growth versus eliminating growth. It's important to think about that. If I'm killing a microbe, I'm getting rid of it. If I'm reducing the growth, it's still present. That means I'm going to need different controls and different systems around it versus if it's dead. Now we're on to our next exercise. You are going to pick a food that you make at your facility or an ingredient that you use at your facility. If you can't come up with one, you can pick a food that you like to eat at home. You're going to use the information that you learned from Chapter 4, and you can also use Appendix 4 and the internet, but make sure you use real resources. No Wikipedia. Be careful if you use AI, make sure that you actually do research to make sure AI gave you a real honest answer and not just Wikipedia. So we're talking about government guidance, research from universities, things from associations that are organized around your product. Okay, so real information. What you're going to do is you're going to identify just one biological hazard associated with that food product, okay? So, for example, if I were going to do tempeh, let me look it up, and I would see that if the fermentation process isn't done correctly, the rhizopus culture can be contaminated with Burkholderia, which can produce the toxin boncrecic acid, which is a pretty bad one. Because it doesn't take too much of boncrecic acid to actually kill someone. So if I chose that, then I would say, okay, I have this particular mold that I need to be worried about. Now I'm going to look at how I might prevent contamination. Okay, so maybe there are particular fermentation conditions that I need to watch out for to prevent contamination. Or I'm looking at my supplies. Or cleaning and sanitation, right? Lots of different ways to prevent contamination. How might I kill it? Does my tempeh actually go through a kill step? Well, if I'm turning it to chips, then yeah, it does, right? There are other ways to kill it other than cooking, so lots of different options there when we think about controlling pH. Or maybe we use radiation. And then the last thing you identify is how you might control its growth. So how do we keep it from growing? Maybe we have refrigeration, or maybe it's a specific water activity, so we limit the available water to the microbes, right? So that's what you're going to go through. You pick an ingredient that you use, or a food that you make, or just a food that you like. And you're going to go through, identify one biological hazard, and say how might you prevent it from being contaminated, how might you kill it, or how might you control your growth. And as an extra challenge, if you choose something like a kill step where you're cooking it, give me a time and a temperature. All right?